Okay guys, for today we're going to review an Algebra 1 topic, factoring, and then we're actually going to extend off factoring and you'll learn one other method of factoring that you didn't learn in Algebra 1. So this is going to be a really important topic for our next unit, extremely important, so you have to make sure to kind of go in, remember this right away, no real time or squeezing in a review day of it, but for the most part they kind of expect you, they being the county, to remember your Algebra 1 skill. So we're going to go in today. Today's all about practicing the factoring concept. Your homework tonight's going to be on factoring, so we're going to get that out of the way and keep practicing. So, there are several methods for factoring. All factoring is, guys, is making a multiplication problem. Okay? That's what it means. When you're factoring, you're breaking down one expression into a multiplication problem. So just like as a review with numbers, factors of 20 are 1 times 20, 2 times 10, 4 times 5. That's factoring the number 20, like listing out multiplication. We're going to do it with variables. So, method number 1, GCF, greatest common factor. So that is always the highest number and then the lowest variable that you can take out if they have a common variable. If you look here, between these two terms, 9 doesn't have an A, so the GCF is not going to have a variable with it, but 3 is the highest number that goes into both of those. So we're going to put 3 on the outside, and then you divide it out. So notice that would leave me with 3 times A squared minus 3. And that's it. There is your factors. If there are 3 terms, same concept. You can see the numbers are 9, 3, and 12. Well, 3 is the highest number that goes into all of those. But look, they all have the variable x. You always want to take out the lowest amount that is, which is x squared. So our GCF there is 3x squared. So you want to divide these terms all by 3x squared. If I do that, that's going to make 3x squared here plus 1x plus 4. And there's your answer. That method is known as factoring by GCF. Okay? Now, two most popular as well. So the front page is all the popular, GCF and factoring these trinomials. Remember, trinomials being 3 terms, okay? And you can see 3 terms. Now, going back, okay, most of these will be quadratics, not always, but the basic quadratic, which is in our unit, looks like this. So I'd make sure to copy that down. So remember, when we're saying A, we're talking about this leading coefficient, the number in front. So, if you notice with these two examples, A is 1, right? This is one of the easiest types of factoring that exist. You have a trinomial and A is 1. Because the first number is 1, you don't have to worry about GCF, okay, unless there's a variable in all of them. Neither of these examples have that. So, when A is 1, ultimately, what you want to do is find 2 numbers that will add to this and multiply to this. That's what you want to do. So you have to think of factors of 6, right? So 1 times 6, 2 times 3. Now think, they have to add to negative 5 but multiply to positive 6. The only way for that to come true is if it was a negative 2 and a negative 3. There's no way 1 times 6 will work for this. So, these are going to be your 2 numbers that fit the bill. In factored form means with parentheses. To get the x squared, you put the x here. And then here, you put those 2 numbers right there. Doesn't really matter the order, but then you're done. There's your factors. You can always check your work. If you go back in and FOIL or do that box method multiplication, it will get you that trinomial. Same thing here, numbers that add to 5 and multiply to negative 36. Start putting it in factored form. And then you have to think, what numbers add to 5 and multiply to negative 36? Has to be positive 9 and negative 4. And there is factored form with the trinomial when a is 1. Now let's talk about when a isn't 1, okay? So, if you take a look here, we're talking about a being, again, the first number in the problem. So this, and this, okay? When a isn't 1, the first thing you want to check for is a GCF. So let's look at these numbers. 6, 5, 4. There's no number other than 1 that'll go into those, so there is no GCF. Now, how we do it here at South River is we say, okay, now we're going to factor using the T method, so draw a T chart. This is how it works. Okay, it still always adds to the middle, all right? That doesn't change. But you're looking for numbers in this column that are factors of 6, so numbers that'll multiply to 6. So I'm just going to try 2 times 3. This is where trial and error comes in. Numbers that multiply to 4. Okay, popular are 2 times 2. Now again, this is how we're thinking, okay, how do we add to this? You're reversing that FOIL process you used to do. See, watch this. You want to diagonally multiply these. 3 times 2 is 6. Put it on the side here. 2 times 2 is 4. Put it on the side there. What you're trying to figure out is there any way these two numbers would add to 5x? Like in FOIL, when you do the outer and the inner, you want to add them up. Well, here, would these add to 5? No, they wouldn't. Okay. I always suggest changing the right column before the left. So you just cross them off, no big deal. Other numbers that multiply to 4. 1 times 4. Let's try it again. 2 times 4 is 8. 1 times 3 is 3. Look at your numbers. Ask yourself, is there any way 8 and 3 could add to 5? Yes, as long as it is a negative 3 and a positive 8. Which makes sense because that means one of these will be negative because it has to multiply to a negative 4 anyway. So the 8 is positive, right? So then that's why this right here is how you got the 8. This is a plus sign in front of the 4 because the 8 is positive. And you put a minus sign in front of the 1. So when you write your factors, the x's always go in the left column and you go straight across with your parentheses. That's how they're grouped. So it's 2x minus 1 and 3x plus 4. And there's your factors. So if you get your numbers down correctly, this will always work. That's why we show it, starting with all our freshmen here at South River. Let's try the next one. Again, 2, 15, and 7. No GCF, so okay, no big deal. I'm going to do the T chart because it's 3 terms. Again, we're still trying to add to 15, so numbers that multiply to 2, 1 times 2, and multiply to 7, let's say 7 and 1, right? So again, you're checking to add this 15. How? You multiply diagonally. So 2 times 7 is 14, 1 times 1 is 1. That makes 15 if you add them up, right? We all know 14 plus 1 is 15. So they both have to be positive, so that means both of these would be a plus, and the x's go in front here. And you group them straight across. So it's 1x plus 7 and 2x plus 1. And there's your factors. And again, you can always check your answer by FOILing out, multiply it out, if you need. Okay, let's try one more. Here, T chart, because there's no GCF, 4, 7, and negative 2. So numbers that multiply to 4, I'll just try 1 and 4. Again, this is trial and error. Well, let's actually try 2 and 2, and I'll show you. So again, these are numbers that multiply to that. Numbers that multiply to 2 are only 2 and 1. And our goal is to add, that should be a -7. Okay? So, let's see. 2 times 2 is 4. 2 times 1 is 2. There's obviously no way 4 and 2, even if they're both negative, would ever add to -7. So these can't be it. Now, if you try to cross these off and switch this order, guys, 1 up here and 2 down here, you're still going to get the same combo. You'd have 2 times 1 up here and 2 times 2. It'd be the same numbers. So this is a rare case. Sometimes instead of switching the right side, the only thing that has more factors to it is 4. So let's try 1 times 4. Okay, so from there, this is where we're going to do 4 times 2 is 8. 1 times 1 is 1. They will add to -7 as long as the 8 is negative and the 1 is positive. So since the 8 has to be negative, you put the minus here because that's how you got the 8. That would make it -8. You put the plus 1 here. The variables always go in the left column. So it's x minus 2 and 4x plus 1. And there you go. Okay, so the front side of this paper has one of our most popular methods of factoring. The back side have some special rules. So we're going to go over those. So let's turn it over onto the back. Okay. So, first thing is factoring trinomials with a GCF. Okay. That means, again, look at the A value. For both of these, the A value is not 1. But don't jump right away to that T-chart until you look at all the values here. 4 can be divided into all of these, so that means you need to take it out as your GCF. GCF always goes on the outside. So that's x squared plus 5x plus 6. Now from there, that is where you have to look, okay, and say, okay, now this A is 1. See, you took out the 4, that's out here. Now let's look at this trinomial. Since A is 1 here, you're just looking for 2 numbers that add to 5 and multiply to 6. So in that case, that's x plus 2 and x plus 3. 2 times 3 is 6, 2 plus 3 is 5. The 4 goes in front, and that's your answer. Okay. Same concept with the second one here. Divide by the 10. Everything here is divisible by 10. So we're going to take 10 out. Leaves me with x squared minus 8x plus 15. See, so when you take out your GCF, you're dividing everything by that number. Once you get that, you can see our trinomial now in the parentheses, the A is now 1. So you're just looking for 2 numbers that add to this and multiply to that. So the only numbers that add to -8 and multiply to 15 are -5 and -3. The 10 goes in front. Just like that. All right. Now let's talk about some special factoring. Okay, special factoring. Factoring difference of squares. Okay, notice difference. That's a vocabulary of math. That means it has to be subtraction. Okay, cannot be addition. Then squares. So we're thinking square roots, guys. Okay, or perfect squares. This is how it works. And it only works with 2 terms, by the way. Binomial, 2 terms. So you can see these 3 examples all have 2 terms, not 3. So here's how it works. There's 2 terms here. This A value is a 1. There's no GCF, okay, between 1 and 9. So then you look at it and you go, okay, is there subtraction? Yes, there is. Are these perfect squares? Yes. See, the square root of x squared is x. The square root of 9, ignore the negative part, the subtraction, is 3. The rule says when you have that, you can write it as x minus 3 and x plus 3. Always a minus and then always a plus. Again, you can check your answer by foiling if you want, and you'll get that. Here, first step, again, you have to do GCF. See, this is a 4. A is not 1. So look at these. Can you do a GCF? Yes, you can take out 4. Meaning I'm going to divide it out. 100 divided by 4 is 25. Then look at what you're left over with. Here is a perfect square. We just did that. The square root of 25 is a perfect square, so it's 5. So you have x minus 5 and x plus 5. That GCF just comes in front, and there's your final answer. Okay. This one is a red flag. I know these are perfect squares, right? I know A is 1, there's no GCF, but when you see a plus sign, this rule does not work. There are no factors, so we write prime. It's not factorable when there is a plus. Okay, and we're going to practice that. Okay, so last set of rules that we're going to do. This one's a little newer. We're going to be practicing factoring difference or sum of cubes. Notice cubes, that means to the third power. All right, so here's the two rules. If you're doing a sum, which remember is plus, it's going to look like this. And yes, eventually you're going to be held accountable for memorizing these. So I would start tonight, okay, because your homework's just factoring. If it's subtraction, which is difference, it looks like this. Now, with these rules, what is A and B? A and B are the cube root of the terms in the problem. So, here's what I mean. First of all, you can see, let's look at this problem. This is a minus, so we're going to use this difference rule here, right? So just for note's sake, I'm going to put the rule underneath. You don't normally have to write the rule. You could just write your answer. But just for note's sake, I'm going to put the rule. Okay, so from here, okay, to get the A, that wherever the A is here, you do the cube root of this term. The cube root of x to the third, guys, is always x. Because x times x times x is x to the third. So the cube root of this is x. So I'm going to put an x here instead. Okay, so where the A is, I'm putting an x. I'll do that over here in a second. Let's worry about getting the B. You never change the signs in the rule, guys, so keep the minus, by the way. The cube root of 125. That's 5. Because 5 to the third is 125. So I'm going to put a 5 there. Now, so this again, guys, your A is x and your B is 5. We're going to fill those in right here. So the rule says take your A, which we had was here, and square it. So that's x squared. Plus, then you multiply A times B. Don't include the minus. The minus came from the rule. So it's just 5 times x, which is 5x. Plus, and then B squared. So 5 squared, what 5 squared is 25. And you're done. There's your answer. Okay. So here, all right, this is a plus, okay? So we're going to do, all right, the sum rule instead. Here's the sum rule. And again, normally you don't have to write the rule. I'm just doing it for note's sake. All right, same thing. Cube root of this is x, so A is going to be x again. Cube root of 1 is 1, so B is going to be 1. And notice I just follow the signs according to the rule. So then it says A squared, so A was x, so I'm going to do x squared minus. Then you multiply these. 1 times x is 1x. plus, and then square that. 1 squared is 1. And there's your answer. Last but not least, same concept. Look here though, 8 and 27. Is there a GCF? Is there any number that'll go into 8 and 27? Nope. So, okay, no big deal. Ready? We're going to use the difference rule. So again, I'm just writing it for note's sake. Here's the rule we're going to follow. Right there. So, to get the A, you do the cube root of this. That is not just x anymore because of the 8. The cube root of 8 is 2, guys, because 2 times 2 times 2 is 8. So, A is actually going to be 2x this time around. The cube root of 27, is 3, because 3 times 3 times 3 makes 27. So B is going to be 3. Once you get that A and that B, you follow the rest of the rule. Now here's the thing. It says take A and square it. It's not 2x squared. It's literally 2x times 2x. So it would be 4x squared. Plus, then you do, okay, 3 times 2x is 6x. Plus 3 squared is 9. And there's your answer. So this is the newest one. You'll get a chance to practice it a lot. But yes, you'll be expected to memorize these rules, so start getting the memorization down. I will have videos posted to Google Classroom as well on these factoring techniques. Last but not least, factoring by grouping. Okay. For this method to do, you must have 4 terms. So you can see anytime you have 4 terms, you do factoring by grouping. See 1, 2, 3, 4. So in this case, okay, to group them, you group the left and the right. Literally, that's why it's called factoring by grouping. So how it works, guys, is you worry about the left side first. Looking at this parentheses, you just want to take out the GCF. The GCF of these 2 terms is 1x. So where does that go? We put that on the outside. Okay, and again, I'm ignoring what's on the right. If you were to divide these 2 terms by x, that would leave you with x plus 2. And remember, the reason why is you can always check your answer. If you do distributive property, you should get what you originally started with. So we took care of that left. Now let's do the right parentheses. Same concept. Look at this. It's a positive 5 and then positive 10. So we're going to take out a positive 5 as our GCF. And that also leaves me with x plus 2. Now, you know you've done the problem right because you want these 2 parentheses to be identical, which they are here. So how do you write your final answer? Because your final answer is in factored form, which is just the 2 parentheses. Well, you bring down this x plus 2, not both of them, just one of them. That's called the greatest common binomial in the problem. So you only bring down one of them. And then these GCFs go in this parenthesis. So it's x plus 5. And it's a plus 5 because we took out a positive 5. If we took out a negative 5, it would be minus. And there's your answer. So, this is your goal today, is to practice these factoring methods. You can see around the room, stations around the room. You will need notebook paper, okay, or there is computer paper here provided for you to practice these methods. You must take this seriously. You go to each station, complete the problems. The answers are provided next to it, but no work. So it's just the answers. You really want to take this seriously because this is not going to go away basically the entire rest of the year. And if you are going to pre-calculus, you are going to be expected to factor. But this unit is heavily on factor. So even with the long-term sub, guys, you will be expected to factor. That's why I'm starting factoring when I'm here, so to prepare you for success for when I'm out. So take out a sheet of paper. There's no calculator all day today, so you should not need a calculator. And if you need paper, there's computer paper up front. You're going to go to each station. You have till the end of class to complete as much as possible. This is your major practice day. We're moving on next class. We're going to spiral in factoring, but this is the longest time you get to practice factoring.